All right, good afternoon, folks, and welcome to Building Awesome Configuration Pages with Lightning Components and Custom Metadata. I'm Dan Appelman. I'm CTO at Full Circle Insights, the author of the book Advanced Apex Programming, and a Salesforce MVP. First, the inevitable forward-looking statement. Nothing is available. Don't make any buying decisions. And remember that everything I explain to you now will probably be obsolete by next year. Now, for my own disclaimer, this is a design and architecture session. I'm not going to show you a lot of code. Now, I know sometimes when they come to speakers, they say, everybody wants to see code, more code, more code. But as somebody who's been developing software for a long time, I have to say, design is much more important than code. If you have a good, solid design, then even if you're a beginner coder, sooner or later, you're going to be able to get your project to work, and you're going to be able to solve your problem. But if you start with a bad design, you can be the world's greatest coder, and your project's probably going to fail. So what we really care about when we're talking about software and implementing solutions on Salesforce or any other platform is the design and architecture. Get that right. Now, why configuration pages? Where does this come up from? When we talk about configuration, we're talking about not application data, but rather the data that's used to control the application, configuring the application. This went ahead too quickly, sorry. I don't know how to go back. Anyway, remember the previous slide. Why would you want a custom configuration page? One reason is you get a nice user interface, you get some branding and so on. That's good. But there's some more important reasons. One is you can do better validation if you have your own configuration page. Yes, you can create validation rules in custom metadata, but you can do more sophisticated validation, and you can decouple the validation, you can decouple the configuration data from the page. For example, you can create a pick list that has certain standard settings. Someone clicks on a particular standard configuration, and it sets multiple items of configuration data. So that's another good reason. Also, if you're creating a managed package, you can create protected custom metadata or custom settings. What that means is that the configuration data is hidden from the standard setup user interface. That means you have to either set it through deployment or you have to set it through Apex. The final reason you might want a configuration page, which really applies to custom settings as compared to custom metadata, is that you can tell a different security story. The Salesforce setup user interface is only available to people who have customized application permission. In other words, pretty much admins. Apex, with custom settings, has the power to write any custom setting, which means you can hide the configuration data, have the user control access to the configuration page security through page security, and then allow non-admins to configure your application. This is not yet available for custom metadata, but word is that it may be coming at some point in the future. Right now, even when you're updating custom metadata from Apex, you have to have customized application permission. Okay, back to the correct slide. Why Lightning? You know why configuration pages? Why Lightning? Well, one reason is because Lightning is the future and the present of the Salesforce user interface. That's a good reason, but not really our reason. Another reason, there we go. I wouldn't have gotten this talk if it didn't have Lightning in the title. Probably true, but also not the reason we care about here. The reason that applies to us is that updating custom metadata from Lightning is really interesting. Now, people have different interests on the Salesforce platform. All of you are probably passionate about different things. Some of you probably love artificial intelligence. Some of you love declarative, some reporting. I'm a software developer, so I love building solutions using software on the platform. And this is just, in my mind, a really fascinating problem. So I'm going to take you through that design process. So first, let's talk about reading custom metadata from a Lightning component. This is a very standard image that many of you have seen already. You go from a component to a controller to a helper to an Apex controller, read the data, and return it. If anyone in this audience is not familiar with this and has not seen the code to do this many, many times, I promise you that there are dozens and dozens of people, mini hacks, trailhead modules, and so on, who would be delighted to show it to you. So I'm going to assume that this picture instantly, you know exactly what I'm talking about. So the process for reading data, the data is requested from the component, the Apex controller comes back and returns the data. Great, no problem. What about modifying the data? Because it's a configuration page, which means we need to modify this configuration data. We need to modify the custom setting. Well, here's the problem. Right now, you request the data, it comes back from the Apex controller, and you cannot modify that data because you cannot modify a custom metadata record. It's just the nature of the beast. So the solution right now is something many of you have seen before, which is a wrapper. What you do is you create a class, and you have various fields or properties of the class that reflect the custom metadata fields and values. And you might initialize this record by passing it an instance of the record. It copies the settings to the class fields, and then you can serialize this class and pass it back to the component, and it's updatable. Now, it turns out that really soon now, I think it's either beta or GA in winter, you will be able to create an instance of a custom metadata record and update it. You will not be able to insert it or update the record in DML. That doesn't work, but at least you'd be able to update the record itself. So you might be thinking, oh, well, this is an example of that advice that's about to become obsolete. Right now, you have to do it this way. You have to create a wrapper. In the near future, you're going to have a choice. Is that the better way? I actually don't know. This is something that it deserves some thought, because there's some really good reasons to always wrap configuration data in some sort of a class. One example is it makes unit testing much easier. So you might be wrapping it anyway, and since you've already done the work, maybe it makes sense to keep using this approach. Something to think about. In software, there are often multiple good ways to do something, and the one you choose depends on your particular scenario. OK, so that's our first problem. We now know how to bring a record up to our Lightning component and modify that custom metadata record. We don't know how to write it yet, but that brings us to another challenge, which is that of concurrency. Imagine for a moment you have two different users who have that configuration page open. And this configuration page is very simple. It has the setting that has a current value of A. And user number 1 changes theirs to B, and user number 2 changes it to C. And they're not aware of what the other person has done. Who wins? What is the value when you save the data? Well, who wins is going to be whoever did it last. Now let's take a look at another similar example. This is a configuration page which has two items of custom metadata, two pieces of data. One has AX. They both have AX to start with. The first user changes A to B, and the second user changes X to Y. What is the setting that's going to end up? Well, it's either going to be BX or AY, but you really want BY, because the first user changed the first item, and the second user changed the second item. So this is a concurrency problem. And you see this in the Salesforce when you're modifying records. You'll sometimes see this. You update a record, and you get a warning that says, we can't save this record because another user has done it. So we want to implement the same kind of thing in our configuration page, especially if it's something that a lot of people are going to be using or using frequently. So the way we do this is when we request the data from the Apex controller, we actually deserialize the return object twice. And in the component, we save it in two places, two different variables. One of them is going to be the custom metadata record that we're going to be editing and changing the configuration. And the other is going to be a copy of the original value. Then, when we decide to go ahead and try to update it, what we're going to do is pass both of them to the controller. The controller is then going to look at the new value, the original value, and reads the current value of the record. It'll look something like this. For those of you who've never seen it before, the way you read a custom metadata record is through a SOQL statement. It doesn't count against limits. It doesn't count as a DML, as a SOQL query, but that's the syntax they use. If there is an existing object, we take a look. We look at the value of that object. We compare it to the original one that was just passed in. And if there's any difference, we throw an exception back to the user and say, hey, somebody else has edited this record. And maybe we'll build a little bit of code to restore the original value and sort of reset that user to their original state. Our third option when it comes to writing custom metadata is that writing custom metadata is slow. We're used to DML being a very, very fast process. So our Apex controller writes data, it's back very quickly. But updating custom metadata, if any of you have ever done this, which most of you have, because every time you do an SFDX push or do a metadata API push or tooling, you're updating metadata. It doesn't happen instantly. So we need some sort of feedback because we know that if users have no indication that something's happening, they're just going to keep on clicking and then they're going to give up. And if you've ever built a Lightning component, you know that having the user just keep clicking a button, it's just not good. You never know quite exactly what's going to happen. So we really want to give some feedback. So the way we might do that is through, say, a spinner, right? A standard spinner that appears when it's doing something. So we might go ahead and the user clicks save. They're updating the custom metadata. We show a spinner, and at some point, when we're done, a few seconds pass, we clear the spinner. You say, OK, great. Now, this return line that says we're done is sort of in this light blue diagonal, because there's a little more to it than that. And the problem is that knowing when the Apex controller has finished updating custom metadata is a little bit tricky. Here's why. We go through our process, we go to the Apex controller, and the way the helper works, the way JavaScript works, is it makes a call out to the controller, sort of an asynchronous call, and there's a callback that gets called when the Apex controller, when the Apex method is done. However, that Apex method has to be synchronous. So it gets to call in from the Lightning component, it executes, when it returns, magic happens, and the callback takes place. The problem with custom metadata is custom metadata in Apex is an asynchronous operation, which means the Apex controller is going to call out to the Lightning platform with an update metadata call. The Lightning platform is going to come back with a callback into Apex, and that Apex function is going to get called, and it's going to say, well, I don't know what to do with this, because that function has not been called by a Lightning component. So there's no connection anymore. There's no way to go back and tell the Lightning component, hey, I'm done, confirm success, hide the spinner, and everybody's happy. So we have a problem here, and the question is how to solve it. Now, it turns out your first thought might be, OK, well, surely that Apex controller, that asynchronous call, has some sort of a job ID that you can poll to determine whether the metadata function has completed. It does have a job ID. That job ID is completely and totally useless right now. You can't query it. You can't poll it. You can't get any status. It's just this number that says a metadata call was made, and hey. So what do we do? Well, it turns out that a really cool solution to that is platform events. And now you see we're combining all kinds of technologies to make this work. So what happens here, and a current good solution, is the component goes out, calls the Apex controller makes a call to Lightning and gets that job ID, and it returns the job ID back to the Lightning component. And that's stored in the Lightning component, and the Lightning component is sitting there, and it's just, the spinner is spinning happily, and it's waiting. Meanwhile, the platform's updating the metadata, and it creates a platform event. The platform event then broadcasts out and says, hey, the following metadata job has completed. Platform event. And somewhere out there, you have a listener. Now, where is this listener? It could be part of your component. You could have this one component that has a built-in platform event listener. But then you're getting into a little bit of complexity, because now you might have multiple components updating custom metadata. You might have one component for each field on your configuration page. do you really want that many components listening to platform events? You can do that, but I think a more elegant solution is to have a distinct component whose sole job, it has no UI, its sole job is to listen for platform events. And what it does is it listens for the platform event, and then it creates a Lightning application event that other components can subscribe to. So it fires that event, the component receives this Lightning event, and it says, oh, look, a metadata update has completed with the job ID that I care about, that I'm listening for. I'm done. It was a success or it was a failure, and get rid of the spinner, and we're done. So this is what I was talking about earlier as being a really cool example, because we're combining Lightning and Apex controllers and the metadata namespace, the new ability of Apex to update custom metadata with platform events to build this complete loop and solve this rather tricky little problem. So let me show you what it looks like. I apologize, it's a pre-recorded demo, but we're on a tight schedule here. So we open up our Lightning resources and open an application. So it's a simple demo app. And we click Preview to bring up our component. And we have a simple configuration page. Maybe it's not awesome, but it does the job. Set a couple of settings. When you click Save, you're going to get the spinner. And you can see it takes a little bit of time. Pop up a little toast, success, and it works. So for those of you who really want to dig incredibly deeply, I am very pleased to announce that the 4th edition of Advanced Apex Programming is actually now available. Sorry, I couldn't get it in time for the bookstore, but it's available on Amazon and so on. And it has an entire chapter on configuration, not just configuration with Lightning components and custom metadata, but when and if you should still use custom settings or objects, and basically a real in-depth discussion of that subject. Sort of one of the big pieces of new material there. And later on after Dreamforce, I will actually post the specific example for this theater session up on the session as well. So with that, we actually have a few minutes for any questions. Yes?
I was wondering what happens if you had like the event listener, and then it creates the event, and then it comes back to the original not controller, the original component.
Yeah.
What if the component doesn't have the job ID yet?
Okay, that's a great question. The question is, what happens if you look at that loop and the application event fires before the component has the job ID yet? It is really hard for me to imagine any case where that could happen. Because if you think about it, the job ID is returned immediately on the metadata request. It returns immediately from the Apex controller, and it should go very, very quickly back to the component and get stored. Metadata is pretty slow. It's a good question. I suppose if I ever see it happen, I'll have to think about it. Any other questions? All right. Well, I hope you enjoy the rest of Dreamforce. I will be repeating this session tomorrow at 11 a.m. for those who are actually still awake and alive on a Friday morning at Dreamforce. If anybody you know who's interested in this has missed it and wants to come and see what it's like. So thank you very much.